Today we are going to learn how to do multiple sequence alignment. Why we will do that? Suppose we got one sequence, full length sequence. Okay, so of nucleotide of any gene. Now we want to find the what if. We know how to find the what if. We can use NCBI what if finder. So from that we can easily translate that nucleotide sequence into our protein sequence. Now we have to find what are the similarity of these proteins of a particular species of our target species, for which species we have done that sequence with the other related species or other vertebrates. Okay. With examples, it will be more clear. So suppose our species is Clarias mark. Okay, that is one catfish. So we have generated the sequence, we have done the sequence of these particular genes, that is IGF-ALS. That is insulin like growth factor, acid labile subunit. Okay. So, and we have done the full length sequence of that. Now I want to know what are the similarity of these genes with the other catfishes and we can say other species, other fish species like carps, okay, or with the zebrafishes, or we can has a similarity with the uh, other outgroups like mouse or human also. So for that, what we will do, we will take our sequence, we can do the protein blast for Claris Marcus in NCBI blast, P blast we can do. Then we will find other species same gene sequence. So from there, from NCBI, that sequence we can, the protein sequence we can download in this faster format that simply we can copy paste in this text file like that you can see. Okay, so we have many catfish sequences and also some salmon sequence, Citrinus, Carpe, common carp, zebrafish, and we have taken out groups as mouse and Homo sapiens human also. So this way we can just copy paste all the sequence. Generally, we can take 10 species. 8 is our fishes and 2 are outgroups, mouse and human. Okay. So this way we have to generate the text file fast. So this we can use for both purpose. We can suppose I want to show in my manuscript, I want to show what are the conserved regions of our protein with the other species. Or we want to generate the phylogenetic tree to show that how closely, which are the species that are closely related and what are the outgroups we can do that. Okay. For the both this purpose, we have to first copy and paste all the sequence of different species. So here you can see all the FASTA formats we have placed. Like if plus carriers Margo is FASTA format greater than species name, then protein sequence means amino acid sequence. Then another species like that you have to do. First species, then this is one is the second species, third species like that we have pasted here. 10 species sequence. Okay. So this is our primary work. This we have to do. Then how we can do the multiple sequence alignment. For that, I have used this BioEdit tools. It is very useful. BioEdit we can use for many purposes. Like after getting our sequence, suppose it is single sequence, we can edit our sequence or we can discard the bad quality sequence from our sequence data. So today we are going to learn how to do the alignment and how to export that alignment. Okay, in publication quality image. Okay, we have to generate the image. You may see in many papers, many manuscripts, this type of image is there. Okay, there are many softwares through which we can generate this image, but I was searching internet, I was not getting. Okay, that's why I am making this video. How we can generate this alignment? Okay, here we can use BioEdit for that purpose. Here you can see for that what we have to do. We can open our BioEdit software. Okay, so here you can see new alignment. You can go to that. So it is open now. So simply for doing alignment, we can simply open that text file where we have pasted all the sequence. Simply we can open that. It is present in desktop, so we'll open that file. It's igf this .txt file. We can simply open that. You can see all the sequence and all the species name is written here and sequence are here. So then we will do this ClustalW multiple alignment. Okay, run Clustal Omega or ClustalW, you can say. Okay, so you can see multiple alignment has been done. Okay, all the sequence. It is almost a 610 amino acid sequence. So here you can see the concept region. So here you can edit sequence. This means this file in many ways. Here you can see, if you click on here, you can see the concept region. Okay, dot dot means concept. So here you can see all the free spaces there, concept, almost concept, but it is somewhat different from the mouse and human. Okay, and that is also possible. Okay, and that is expected. So here many way you can do that simply by clicking. So as per your needs, you can make it black and white also, like that. If you want to see the concept regions, so black means full black means it is the concept region, and less black gradient. If you see the gradient, more dark means it is concept, less dark means it is not concept. Here you can see it is not concept region. Okay, for salmon and for cycling dark view, it is somewhat different. So now this way also you can colorful and make it colorful also, for mainly for the manuscript for publications we generally make it black and white. So the question is, after this it is clear many videos are available, but main thing is how we can export this file. Okay, so and what problem I have faced during exporting. So for exporting in graphical view, you can see, you can go to the graphic view. Now I've come to graphic view. Okay, and these are the different options we can use. Title should be left or not. You can simply by clicking that the different option that there it is said black and white you will make or colorful you will make. You can do that, but for publications we generally do this one black and white. So this black one is the uh, concept you can see, and we can able to see that by seeing this sequence that. And most of the portions of this, or we can say regions of the protein is conserved among all the species. Okay. So here I have faced this problem that our sequence is here you can see per row how many residue will be there. I have said is 150. So it should become 150. But you can see here it is coming white. Nothing is coming. So other sequence they are not coming. So how we can export that? If we export like this, so I was facing this problem. That's why I'm making this video. So others may face the same problem and they can solve. Okay. So here you can say it is white, nothing is there. If you export this, so this much portions only will come. Okay, up to 40. Then it is starting from 160. So then 50 to 150, all the sequence it is not there. So what we can do for that here, this is the thing. Okay, so for that we have to increase this page width. Okay, that was not set previously. So after searching that how I can solve the problem, how to solve this problem, and I have found this way. So if you are not finding this problem, so simply you can do that. So if you found this type of problem, so you have to increase the page width, then you can click on redraw. So you can see now it is coming. Okay, 150. Okay. So you have to increase the width. If this page width is less, so you will not able to find the whole sequence. Okay. So for me also, I am making this video because in my channel there are many videos that I have made so that I can recall what mistakes I have made, okay, during these things. That is the purpose. Okay, and the purpose is also to make to help others if anyone facing this type of problem. Okay. So here you can increase the page width, inch you can increase. So margins, all the things are there. You can change the color from here, black. If you want to make other color, you can make it. So that is the things. And the residue number also you can change. Per row it will be 150. For me, I have kept up to 150. If you want to keep up to 100, it is based on your choice. Okay, or you can say based on your amino acid length. It is short length, so you can reduce the per row residue also. So all the things are there. Here from here you can change the actually front type and size also you can change. So this way. Now how we can export this? Okay. So in many videos it is saying that you can simply export from this one, export as rich text. But I have faced some problem after exporting like this. So I didn't get the sequence properly. Okay, it is overlapped. I don't know I have made any mistakes or not for doing that. So, but I didn't get that properly. Okay. So then I found another way so that we can simply take this picture in Word and we can paste it in Word. So that way we can do from this edit. Okay. So copy the page as bitmap. Okay. So this is the options. Copy the page as bitmap. So you can simply copy. Okay, then you have to open Word, then you can paste it. I have pasted already this one. It is looking small, so you can increase the space size so that you can able to see. Here you can able to see the same sequence is pasted. So this is actually one image that you can use for your publication. You can use for your manuscript. Okay. So in I have sent one manuscript there. The reviewer said that to make this type of image, okay, so that they will able to understand that what are the conservations between the species for that particular protein. Okay. So this way also you can able to understand. So black color means you can see many regions of this protein are highly conserved for, and this obviously for 8 fishes and also for human and mouse also. But this region you can see it is different. Okay, this extra part is there for these two species, that is salmon and cyprinus calcio. So this way you can able to generate you can do the multiple sequence alignment for your proteins, and also you can export it easily. Okay, so if you want to export in color format, so simply you can click here. Okay, so you can see the different your this one will come, your amino acid will come in different color. So for publication purpose you can use this one. So it is showing the conserved region. Okay, so that is the purpose for today. I hope this video is useful for you, and it will be helpful for me also if I forget in future. Okay, I can use that video for making this tree. Yeah, for making this type of images. Okay, so this files also we can use for phylogenetic tree analysis, because that alignment file we have generated, that the alignment file we can use for making the phylogenetic tree also. So in later video we'll discuss about the how we can able to generate the phylogenetic tree, okay, using Mega software. Okay. So that is the purpose. That is okay. That's all for today. So here today we have learned how we can export the multiple sequence alignment for publications purpose, quality image we can generate. So there are many software you can use, but I have used the BioEdit. That's why I'm sharing it. Thank you all. Thank you. Thank you.